Alright, my name is Edgar Perez, and the material that I chose to investigate is cellulose nanofibrils through flow assisted assembly. So, in this first picture, we're looking at the cellulose nanofibrils, which are right here, which are being flown into what is 1 millimeter wide steel made like canal. And as you can see, this blue part right here just represents the deionized water that is being used in this method, and the lighter green, I guess you could say, is represents the acid that is pumped into this passageway. And here you can see a close up of what the alignment looks like once it passes this area, and it right here as well, right next to it. So to get into it, this process of as I said before, the passageway through water, it makes it so that the cellulose nanofibrils become oriented in only one direction, so it becomes anisotropic. And the thing with this is that it reinforces it, so it's all becoming stronger together, as opposed to it being over here when it's all scattered and everything like that. And what the acid does with the cellulose nanofibrils is that it completely removes the electrostatic interference that may keep the cellulose nanofibrils from being close together like this. So by removing that strip of any sort of electrostatic charge, it makes it so that the cellulose nanofibrils are able to join up together, and the water is just there to help them flow together, so they have a means of I guess the transportation. And here you can see this is a step one, which represents the nanofibrils, so it's it being like all over the place, and the arrows represent here on the side that they're not moving as much, and then the third is that it's still not moving as much, and then the fourth finally is that it finally aligns itself in one direction. This next image right here, it shows the comparisons between the cellulose nanofibril lengths. So the CNF 550 has a nanometer length of 590. CNF 820 is 683, and CNF 1360 is 391 nanometers. So what they found is that the shorter the nano length fiber length, or the nanofiber length, the worse it did actually. And the reason why the CNF 550 and the CNF 820 were able to perform so similarly was due to the average lengths actually being pretty similar. So that's what this shows here. It's another one of RH just represents relative humidity. So they did more tasks with comparing it with humidity. And then lastly, the one they chose to demonstrate over here, the comparison was with cross-linking. So it demonstrated that the CNF cross-linking actually produces much stronger ultimate tensile strength in the material. And this letter D over here just shows the comparison between the Young's modulus and the ultimate tensile strength between all the ones that were tested. This diagram right here represents the best strength and stiffness to density ratio. So as you can see, steel's right here, and the reason why this present work is so up there is just because of the density of the material. And the other ones to compare it to is dragline silk, which is pretty similar to what is seen in spider silk type of thing. And then lastly, the table that I want to go over is the fiber materials with their strength, stiffness, and the relative year that they were performing the experience on. And as you can see, as the years go on, and it's from 2016, 2011, 2015, they were doing experiments, and they were only able to around clock out around like 300, with the most being 576. Oh, well, in the 850 in 2017. But with this new method of the passageway assisted waterway, they can achieve a strength of up to 1,570 megapascals, which is the most out of what they have tested before, as well as the stiffness, which is measured in GPa, gigapascals, has a stiffness of 86, again being the most of what they have achieved in prior years. So that's pretty impressive for what it is, for the fact that this new nanocellulose fibers are eco-friendly. So that means that they're made completely from renewable energy, or sorry, from renewable sources. And it's exciting to think about all these breakthroughs that scientists and researchers are making, especially during this time. So we'll see what they can do next. So thank you